little bit of this area. First, we have our first aid kit. In case of any injuries that anybody may have, regardless of the size, you're free to use, you're able to just take. But in order to take it, please let me know. I'm the student lab manager that is responsible for your guys' section. And no matter how severe, we need to know because we need to report incidents to the NIH due to a campus contract with them. We also need to know if it's a repeated incident. So if something is breaking all the time, why is that happening? We need to know that so we can find the source and fix it, okay? But this is where the first aid kit is always gonna be. In addition to that, you guys noticed that everybody came in through this door, right? And there's a sign on top of it that says open, or the lab is open right now. This is gonna be the door that is unlocked to this lab. However, to get out of this lab, there's two exits. So one on this side and the other all the way over there. That door is almost always locked from the outside. So we just recommend you guys just automatically go through this door when entering the lab. Exiting as well. We don't appreciate people going that way through that door. Okay. Moving forward, we have this emergency response guide. If you guys have taken any other lab courses here at Davis, you will have seen this before. It's pretty self-explanatory. Everything is on here. Based on whatever safety situation you have going on, everything's listed for what you should do. Next thing we have right here is going to be on this glass cabinet. This right here, it has a BUA. Does anyone know what a BUA stands for? Totally cool, no worries. BUA stands for Biological Use Agreement. So this is the list of organisms we currently have permission to genetically engineer in this lab space. So that's transgenics, right? So all organisms we work with in the lab are BSL 1 or below. Remember I mentioned that before. But that means they have very little chance to make you sick. We also don't work with genetic material that code for hazardous or toxic proteins. But if you have any questions about anything on this list or you're interested in that, please feel free to email Andrew and he can get you in contact with the right people. Moving forward, this is the list of the emergency numbers that I mentioned that we would need for using that landline phone. So this has all the numbers because sometimes, sometimes if you forget, like in 911 is the only one you know, but we actually need student health services, their phone number is listed here. So this is a good place to go back and check. While we're here, and we talked about PPE a little bit, sorry, I'm just gonna go by lab coats. Sorry. Okay, on lab coats, we absolutely require people to have lab coats on when working in the lab. Students, you are encouraged to bring your own lab coats, and if you are, you can leave it here in this lab. However, it needs to go on this side, which says personal lab coats. You'll take a blank hanger with nobody's name on it, and you will label it with tape, and you can leave your lab coat and hang it there. However, if you don't want to be bringing in your lab coat every time and it's a hassle for you, you're more than welcome to borrow our lab coats. However, if you do so, please put them back on the hanger you grabbed it from and the correct size so that the next students can find it. And we ask that all lab coats be put right back onto the hangers once you are done using them. So not on the ground, the lab doesn't get messy. It's part of the responsibility of you guys as students. So please make sure you do that. And then I mentioned this already, but PPE needs to be taken off before exiting the lab. If you're transporting something outside of the lab that needs you to have your gloves on, you would leave one glove on and the other hand ungloved so you can open knobs with that. And you'd be transferring that thing on like a cart probably, but of course this doesn't really apply to big RT, it's more training for any other safety things that happen in this lab space. So right now, let's go ahead and go out. And as you pass the door, there's a sign on there with the evacuation map. It's the same image that we saw earlier on the presentation. Okay, thank you. I was gonna, okay. Yeah, so this sign right here that says lab is open, it'll probably be up like all the time when we have sessions going on, because if you notice here, we have a lot of sessions that happen in the lab space. However, my personal policy is that if I am in lab, you open the door is unlocked, and I'm not there, we ask that you would stay outside along like the hallway or in that room on the side. Either's okay, just until I get there so we have respect for the previous session that's probably finishing up in there. But if I'm in there, you are more than welcome to go in and start getting ready and set up. Grab your gloves, lab coat, all that. Okay, and then we already talked about evacuation meeting location. Just to point out, there are 2 fire alarm poles. There's one closest on that side, I'll be pointing it out, and one around the corner as well. And the fire fire alarm pole station is used for activating fire alarm anytime there's a chemical spill or any other emergency in the building. Okay, so let's just keep walking this way. And speaking of emergencies, I'm going to be pointing out the area where we will go in case of an emergency. Again, please don't use the elevators. They will stop working in the event of a fire. You would be taking these stairs here and going out to the grassy area that's right over there. Okay, so just for courtesy's sake as well, bathrooms are going to be on this side, men's and women's, and also a water station right there, except I think they're building it right now. So there's another one directly underneath that with the same floor, with the same exact format, or also all the way down the hall. Same thing. Okay, so we can go ahead and go back inside the room, and we'll continue our presentation over there. Okay. Okay, so our first thing here, we have a PRUSA 3D printer. This is used by some of the research teams. Sometimes the printer will be hot when it's, sometimes the printer will be on when it's in the lab. But we want to be careful of the printing bed and the nozzles. Both can be very hot, so over 100 degrees Fahrenheit. And using the 3D printer does require additional training. So please don't touch it if you're not trained, but you can admire from afar. Be careful to not go near it when we're using this microwave. So you guys can keep following me and make like a half circle this way. We're just going to keep going all the way around. I'll be coming back to microwave safety as we go over there. We have a second microwave, but pointing this out for you guys right now. Moving forward, we have the OpenTrons robot. This right here is an automated pipetting robot. This was originally used by iGEM. And if this is something that you're interested in, because you can code commands onto the robot with ChatGPT. But if you have any questions or you're interested, please contact Andrew. Moving forward, we have our centrifuge station. So with centrifuges, there's one rule that we like to stress the most. It's like the most important one. Does anyone know what that is? Balance. Awesome, exactly. So the most important rule for centrifuge is balance, and especially more true for the large centrifuge. So we want to make sure we balance our samples in the large centrifuge with a water balance of equal mass. So water balances, we have a few right here listed here, but it also depends on what you guys are putting in, if you're going to put in a PCR plate or not. And so we'll talk more about that during your PCR module, but it's very important that you have balanced your centrifuges, and then you will always wait until the centrifuge reaches full speed before walking away. If it's not balanced, I'll tell you a little story. I literally didn't think that centrifuges being unbalanced was that big of a deal until I asked Andrew, and I was like, oh, what even happens? He was like, let's find out. So then he put them in this large centrifuge, and it started shaking everything, including the station and the ground. I literally could feel it under my feet. And then he finally turned it off, and I was like, that was so scary. I will always balance my centrifuges from now on. So yeah, in case it's unbalanced and it starts shaking like that, you can hit this red button that says stop. But again, balance is key. We just do it from the beginning so you do not damage the machines. So keep that in mind as we keep going. Now all the way at this corner, we have our plate reader. As we are doing Big RT, this is really important for your guys' pipetting module. We'll be scanning your plates in here. Just know that it requires additional training to use. You guys will not be running it, but you'll be using it near it at some time. Just be aware. It's a machine that has liquid and electricity, so just be aware. Okay, right here along this wall is our gel electrophoresis station. So right now our units, like the gel units, are actually a little further away. But that's where the power supplies are. And they basically drive an electrical field through salty water. But that's like a really like lame version of what gel is. Like it's much cooler than that. But if you are not careful and you touch the liquid while it's on, it can electrocute you, which is obviously not good. But the box is built so it's very difficult to electrocute yourself unless something breaks though. So the main thing is that if you see anything that's broken, if the box is broken and the buffer is leaking out, or you see sparks flying from the unit, please let me know immediately so we can turn that off and make sure that everything is safe for you guys to use. Always clean up the spills next to the gel boxes immediately. We have paper towels, and I'll be pointing out where all those things are on the day of we do that module, or also today as we go through. Yeah, so same goes for this entire station because this is exactly where we'll be putting all of our gel stuff. Moving on, right here, we actually have a water bath. We will not be using this during Big RT. Just know that it can get hot, like not because of what's in it. Sorry, the water bath itself machine will not get hot, but what is inside it might be very hot. So please just be cautious when you guys are working with it or around it. I just mentioned the microwave when we were all the way on that side. This is the second microwave that we have here. It's not for food, as obviously, as we know. But the glassware that we'll be putting in our microwave can be very hot. So you will be using heat resistant gloves just like these. There were a couple over there on that other microwave to take anything out when you are handling. Very, very important that you use heat gloves. Okay. On this side, we have our UV transilluminator. This is our gel reader. We'll be using it during the gel module. The most important safety, with this is that UV light is bad for you, right? As we all know, and it uses UV light to read the gel. However, this does have a very nice safeguard where it will not turn on unless the door is closed. So the UV light should not affect you in any way. It should not be near you. However, if that malfunctions and something happens and you just see light coming out of here, please let me know immediately so we can get this turned off and the safety for all of us is going well. Okay, and then moving a little forward, we have these two -20°C freezers. They will begin to melt if the door is left open. If we also don't latch the hinge right here, it'll also melt. And that can be a really big loss of our expensive reagents. Additionally, opening and closing the door too many times leads to an ice buildup, and it makes getting things out kind of pretty difficult. So if you can't find what you're looking for, which again, I won't ask you to be looking through these freezers, but in case that ever happens, you would need to ask us immediately. No food, drink, or flammable materials will be stored in these freezers. Does anyone have any questions at this point? Okay, awesome. So this right here, this station has some Bunsen burners. There's also 2 more stations in the chemical room. It's important that we note that gas is invisible. So if you smell it, it smells like rotten eggs. Please let me know immediately because we got to check that the burners are off as soon as possible. This is a little note for the station. You also notice there's some hair ties. So if any of you are like me with longer hair, your hair needs to be tied back for basically all of our labs. So you are more than welcome to take it. Don't put it back in there. Just keep it. It's yours. Yeah, and they'll be right here this whole time. Also in this area, we have flammables, and the safety hazards that are associated with flame are as follows. Sometimes we use alcohol, which is a flammable liquid, next to the Bunsen burner. To avoid the fire, we want you to aliquot your amount needed before working with the Bunsen burner. So any aliquots of flammable liquids should be less than 100 milliliters unless sealed in the flammables cabinet below the fume hood. If an alcohol spill occurs, we're going to wipe it up with paper towels. But if there's a fire on the benchtop in a contained area, we're going to let it burn out on its own. But if the beaker with the alcohol is on fire, we're going to cover the beaker with a non-flammable item like a tip box, something like this blue box right here, and it'll smother the fire. For larger fires, if it spreads beyond the alcohol Bunsen burner area, we will use the fire extinguisher and aim at the base of the fire, and I will be pointing out where that fire extinguisher is as we get into that chemical room next to us. Again, if you're not comfortable, and who would be, but first thing is you're going to raise your hand and ask me for help, and I will come over and help you. Don't panic. The reason we also smother and put out larger fires is because we use slow burning alcohols. Okay. The last thing in this area is this microscopes with UV light sources. So the thing with these is that they have a unit attached to the side that uses UV light. It's very cool, but if you accidentally turn it on, it's just a little switch on the side. Please don't immediately turn it off. First thing you will do is tell me, and then we will wait 15 to 20 minutes, or I think 15 minutes should be sufficient to turn it off, because there is a mercury bulb inside of it, and if it pops, it's both dangerous and very expensive. So that's very important that we take note of that. So yeah, next thing we have here are the trash situation going on. So these right here, these bins that are lined with black liners are normal trash bins. That is where gloves, weigh boats, anything that are big, like the little scupulas, those big things, they are gonna go in here. If you have any tips and tubes, like your tips that you will be getting out from the pipetting lab or any tubes from PCR, they're gonna go on these tabletop buckets, okay? Those tabletop buckets get emptied into this biotech collection, no hazards bin, periodically. And then the last thing is that this bin right here is for broken glass only. No gloves. That is the biggest thing. No gloves in there, only glass. So remember, this right here, gloves, weigh boats, anything big, all the small things that are tips and tubes on the tabletop trashes, which will be empty here, and then no gloves, but just glass. Okay, so let's go ahead and go into this chemical room, and then we'll go through that next. Okay. Okay, I think everybody's in here. So first thing to get started with is this eye wash station. So pretty sure you guys have seen this before, but if any biological or chemical material splashes into your eye, you will be pushing a flap down right here to turn on the water. If you can't see, ask someone to guide you. You'll be removing your contacts and your glasses, immediately rinsing your eyes for at least 20 minutes. Of course, when this happens, you would first notify me, your student lab manager, Andrew, and anybody else that was an instructor of the course. Anytime the eye wash is used, it's very important that we also report it. The next thing that we have here in this area is our safety shower. So if you spill a hazardous chemical material on exposed skin or yourself, you will remove all the contaminated clothing. The door to this room can be closed to maintain privacy, and pull the metal handle right here to turn on the water. Notice that there is no drain on the floor. Because contaminated water cannot go down the drain, but your safety is the most important thing. So in the trade-off of your safety versus flooding the lab, we're gonna take your safety every single time. So you will be rinsing your affected skin for at least 20 minutes. So again, same thing with the eye wash. If anything happens, you would notify me, your student lab manager, Andrew, and anybody else that is an instructor of the course. Okay. This thing right here is the laser cutter. Without containment, it's a class 4 laser, which is capable of burning materials and skin on contact, but there's a protective casing around it that greatly increases user safety, making it a class 1 laser. So just for reference, class 2 laser is literally like your laser pointer. Yeah. But if the metal case or the fiberglass lid is broken or shatters, we would immediately turn this off, unplug the unit, then contact the student lab manager, Dr. Faciotti and Andrew. But currently the laser cutter is broken. When it does come back online, there are special safety glasses that are designed to block the wavelength.
I think it's fixed now.
I think it is fixed now too. So ignore that part about it being broken. It is fixed. But when it is in use, the door will be closed and there's a sign that says like laser cutter in use that'll be on. And then it is important that you guys know that there is a fire blanket underneath in case it catches fire. Speaking of fire, there is a fire extinguisher right here. That's what I was talking about when we were on that side. Okay. Moving forward, we just have, sorry, I'm gonna go by the sink. We have our spill kits. So remember we talked about biological and chemical spills? Those are gonna be located right here, the kits. So yeah, the chemical spill kit is going to have the absorbent powder, gloves, goggles, and a sheet to cover the spill. That's actually all in this plastic bag right here. And then for biological spills, bleach spray, paper towels, that's all gonna be right here, okay? So it's all located right here, and any questions that you have about that, you're more than welcome to ask me during that time. Paper towels are gonna be right here. You guys will be coming back for that later on throughout the course. This right here is the fume hood. So most important thing when using a fume hood is that the window sash needs to be below the mark on the side of the hood. This is what we use when we work with hazardous materials such as carcinogens, reproductive toxins, flammables, or corrosives. These are actually stored underneath the fume hood. But having a fume hood prevents any fumes from those chemicals from coming out, also saves us electricity. So if anything is leaking from the cabinets underneath, also from the fume hood, please let a student lab manager or Andrew know as soon as possible. We need to take care of that. On the right side of this fume hood, we have the chemical waste bin. This is where hazardous chemical waste, so phenol, acetone, chloroform, etc. This is where we store it for disposal and pickup by environmental health and safety. After that, we have this last machine in here, which is the autoclave. So an autoclave is like a large pressure cooker, basically, to like very much simplify what it does. But it gets very hot and it builds pressure. So the thing we need to remember is that the lid of it is very hot, most likely. So the number on the display is actually the temperature reading in Celsius. So please don't lean on the unit. Please don't open it without training. If it says cool, that does not mean it's actually cool. It can still be cooling. So it might still be over 100 degrees Celsius. So please just be aware, be careful, and don't touch it. So let's go ahead and go out and around this side by the curtain. Okay. So first thing we have here are the gloves location. These are in these cubbies labeled by size. We got size extra small, small, medium, and large as of right now. If they're provided by the lab for you guys to use, if they're running low, please let me know so I can let Andrew know, and we can restock them for you. The lab also has cryogenic gloves up here for cryogenic work. So these are these blue gloves up here in the top cabinet for accessing the liquid nitrogen dewar and the negative 80 degrees Celsius freezer, which are behind me on this way. The metal bin also has chemical gloves for work with certain chemicals requiring an SOP, which is like this one right here. Cut resistant gloves for working with broken glass, sharps, other cut hazards, but all these things are right here. Again, what's most important for you guys is right here and knowing that the cryogenic gloves are up here. Protective eyewear is going to be in this green bin right here. We have a lot of different types of goggles that are required. But if you want to bring your own, you're more than welcome to. We highly suggest using the glasses one that's in here. They go over your glasses. They don't fog as much. And Andrew says they look cooler. So behind this curtain, we have a few more things that I got to tell you guys about. So all the way down on this side, this gray, huge machine, is the negative 80 degrees Celsius freezer. So this is the one that if it's left open, same thing as the other freezers, reagents and experiments will be ruined. So you want to open it very quickly using the cryogenic gloves. Again, they're going to be these ones up here. We have to use those to prevent frostbite on your hands and retrieve what you need. It's very important for long-term storage and protection of biologics, so things like RNA and bacterial strains. Okay. Also next to it, more closer to us, we have our 4 degrees Celsius refrigerator. So in here we have a lot of ongoing projects. That's actually where we store your PCR products until we see you in the following week. That's going to be right here. Everything needs to be labeled accordingly because we have a lot of things going on in there. Then lastly, behind me we have this mammalian cell culture room. You have to have more safety training to go into the room, and it does contain the following. It contains a BSC, which is a biological, biological safety cabinet? Safety cabinet? Yeah, I think I got it right. Yes, thanks. Biological safety cabinet. And it creates a sterile environment using a curtain of sterile air. It's most important for mammalian culturing in particular right here. And it protects your samples, but not really the user. So basically there's a difference between this and the fume hood. The biological safety cabinet protects your samples from you, but the fume hood protects you from whatever's inside the fume hood, okay? The fume hood blows air out of the building. So a little different. We also have the liquid nitrogen dewar in here. This contains liquid nitrogen, which is used to store mammalian cells. Liquid nitrogen is really cold, as we all know, and it requires you to wear cryogenic gloves, face shield, and full PPE. Also in that back room are CO2 incubators with CO2 tanks. This is a potential suffocation hazard if the tanks are leaking. Tanks need to be mounted to the wall at all times in case of earthquake or other instances where they may be knocked over. Andrew is the only one that can move the tanks. If the regulator gets broken off, the top of the cylinder can become a torpedo. Not to scare you though. We won't be using it. It's over there, and Andrew takes really good care of making sure that the lab is safe. Last room, this is our very last thing. In this room, we have our shaking incubator. It's on right now. Usually it's at 37 degrees Celsius. If you are using it as part of the research team, again, we won't be using it in Big RT. You have to wait till it stops moving to put things in there. You want to watch to make sure it starts up again once you leave. After that, we have 2 thermocyclers that are here towards the back. We will be using this for Big RT. The biggest thing with this is electrical danger. If it's malfunctioning and there's wires anywhere, sparks everywhere, please let me know as soon as possible. I will let Andrew know as well. On top of that, there's a metal plate inside of it. You guys will be looking at it because you'll be putting in your samples there, probably when we go through Big RT, but it can get hot, so please be careful with that. Last, we have our 37 degrees Celsius incubators. There's 2 right here. These are shared incubators for the whole lab. So you don't know all the strains that are going in there. It's important that you close the door when you're done. Plates go agar side up so the condensation doesn't happen on the lid. Does anyone have any questions right now? Okay, great. When we go back, I'm gonna have you guys sign the documents. We have one more task that we have you guys do, and then you'll be able to head out. But that's it for the in-person.